been to spend 6 weeks with the BBC, broadcasting house, doing a mixture of radio, science radio, and news online.
So I'm Becca, or Rebecca, either one works, and I'm editor for Nature Geoscience. And as I'll explain a bit later, you'll probably know most of us for publishing scientific papers, so communicating science to scientists. But another part of our job is communicating that science to the scientific, interested general public, and primarily through writing press releases. So we have both arms to our kind of outlook and communication: science for scientists and also science for the general public.
I'm Medina Paitan. I'm a biogeochemist at the University of California in Santa Cruz, and I am equally passionate about education and communication and outreach. So I've got these two aspects as part of my career.
And I'm Tom Harkill. I'm the press officer for the Goldschmidt conference. I'm actually freelance, so I only work for Goldschmidt part of the time. I work for some other organizations for the rest of the year. And in fact, after I leave geochemistry in 2 weeks' time, I'm going to do a neuroscience conference in Copenhagen. So trying to get my mind switching from one to another is quite difficult. So if you see me slowing down, this one.
Okay, so we'll get started. We have some formal stuff and some time for you to do something, and then the questions and so on. So first of all, to talk about communication, when you as a scientist want to communicate, you have to keep in mind who you're communicating with, and that differs depending on your audience. You can communicate to policymakers, to scientists, to teachers, to journalists. All of these are audience. Now, the way you present what you're doing will depend obviously on who you're talking to, their agenda, and their background, and so on. So your story changes depending, or the way you present what you're saying will differ depending on your audience. And that's the first and most important thing about communication, is to know who you're communicating to. But before we go there, quick question. Why do you think scientists should communicate their work? Anyone? I would like you to participate, so I don't want to call on anyone. I would like you to volunteer. There you go. Why should we participate? Communicate.
I think it's very, very important for a scientist to communicate, to spread the word about his work, or her work, because this ultimately will be beneficial for the person, like getting more funding, getting more attention.
So the public, perfect. The public fund us. They need to know what we're doing. So that's one reason why we communicate. Another reason.
The work that we do in the lab or the field doesn't matter if no one knows about it.
Yeah, we do something that is relevant, that people should know about because it could impact their life, their choices, and so on. So we want to communicate that.
Because it's cool.
It's cool because we
work
love
on things that we're passionate about. And actually, when you communicate by in a understandable way to people, they're also really keen, especially geology.
Yeah, so all of the above is true. You know, we have something to say. We're expert in our field. We care and should care about spreading that information. The public funds us, and surprisingly, another reason is the public actually trusts scientists. There's a study that was done that shows that if you look at it was published in 2002 by NXF, you can see the percent of the public's trust on different categories, and you can see about 10% of people think that, or trust, or have confidence in the information they get from the press or from the TV, or even from education or the Supreme Court. The scientific community is right up there, slightly less than the Supreme Court. So because we have this kind of trust by the public, they think we know something, that's our job to actually use that to our advantage and be able to communicate what we're doing. But in order to communicate, it's not enough that we talk and say something. If we talk and there's this red line over there, a wall between us and our audience, then if they don't get it, it's as if we said nothing. So in order to be able to communicate, we have to actually be able to transfer the message to our audience, and they need to have this aha moment and to get it. Because otherwise, we haven't communicated. We talked, but we haven't communicated. So in terms of communication, our message, or why we're doing what we're doing, has to fit our audience. For example, if we're talking to policymakers, they need to know how is that important to the people who support our party, will it increase our vote, to managers, how will that solve a specific problem, to NGOs, if that is consistent with the programmatic values of the organization, is it groundbreaking if you're talking to scientists, to the media, is it newsworthy, and to the public, how will that impact me, my family, my community, what is there that I can benefit from? And this is an example of, for example, communicating climate change. So the same kind of information to a surfing magazine, what's important for the surfers, the impact of climate change, is how will that impact the wave height that they're going to use for surfing? Because if the climate change will change the pipeline, which is this big surfing competition that they surf, that's what's important for them. For economists, it might be important, how will that impact the markets? So the same kind of scientific knowledge has different implications for different communities, and that's really important to keep that in mind. So in order to be able to be better communicators, this is something we can learn to be better. And the idea is that the way we communicate with each other is very different than the way we communicate to the rest of the world. For the scientific paper that you write, you usually have a title and an abstract and background, method, results, discussion, and you focus on all of this. You kind of build the picture from the bottom up, from all of your groundwork and your methods, and then at the end you have the message of what all of this work concluded into. So the conclusions are the end. For the audience, typically what they care about is, so what? They don't care about how you actually spend half of your life in a small clean lab pipetting or looking at columns drip, and that you separated these two ions by this many minutes as they were dripping or whatever. What they want to know is, so what? What is the problem? What is the issue? How do I benefit from that? And you have to be able to translate the way we normally as scientists communicate with our own group, with other scientists, into this different style where you cater it or market it or change it to be relevant for the audience. And to do that, there is, we're going to do some exercise, and Becca's going to give you some paper. If you have your own paper, you can take it out. And what we're going to try to do is you think first about the audience. You see at the bottom there, audience. Think about the audience you're going to communicate with, and then your issue, something you're working on. So think about your thesis or the next paper you're going to write. That would be the issue. And then start and fill these boxes. I don't want like a whole page in each box. There should be no more than a sentence per box. So it should be short. You have to define the problem. Why are you doing what you're doing? Why is that important? What you found with the solutions, and how the audience would benefit from that. I'll give you about 5 minutes to do that. I'll put an example here so you can see. Before that, one thing that we all have problems with is our jargon. We assume that our language is understood by the rest of the world. Unfortunately, it's not. Here's just a few examples of things we use routinely when we write our papers. For example, manipulation. I set an experiment and manipulated the pH. The public's meaning is that you're tempering with something. What we mean is where it's a scientific processing of the data or setup of the experiment. So all of these things, enhance means improve to the public, intensify or increase to us. So be careful with your jargon. When you write these, when you fill this message box, make sure that you're using terminology that your grandma will understand, assuming she's not a scientist that received the Nobel Prize. Or my grandma will understand. She's a seamstress. Okay. Here's an example of a message box. So this is a work about sea otters that were found dead. There's a disease that a lot of sea otters were found, and the sea otters were dying. They had a brain disease that was transferred by cat feces. It's the disease that decreases the population, that's impacting humans that life to them, but also health-wise, they cause miscarriages. The solution, don't dispose of your cat feces in the sewage, put it in the landfill and so on, and the benefits, you know, you can have both cats and sea otters and so on. So this is a way that you, instead of saying how you measure the density of the bacteria in the feces and what temperature you incubated the bacteria to see the percent growth and all of that, this is a way of giving the same information to some community of interest. That's just one example. I'll leave that on, or I'll maybe switch to another one. And I'll give you 5 minutes to do your own, and then we'll have volunteers come and share. You all have papers and pencils? So I want to see you writing. Yes?
I need a pencil.
I can give
Does
you.
anyone have a pencil? There's an response here as well.
Here.
Look, thank you.
You need a pencil? So if you're here and you didn't take lunch yet, there's lunches in the back. come over here and volunteer to read their message box, and they'll get feedback from us. And they'll get something else from me, so. Can I get a volunteer? Okay, 1, 2, 3, we've got 3 come up here. Yeah, why don't you? Yeah, come on first, tell us first what's your audience, and then
Very.
I hope tell who you are.
Oh, so my name's Kirsty, and I'm from the University of Edinburgh. So this is aimed at a very public, broad audience, so maybe through newspapers, that sort of thing. Issue: global warming. Problems: Arctic warming may cause dramatic change in traditional fishery grounds. So what Arctic fishing grounds are the main source of fish for many countries, especially in the Arctic region. Solution: massive Arctic research program to collect data, to feed the numerical models, to provide future projections, to mitigate the effects, to inform decision making. Benefits: we may still have fish to eat, and we may be able to source the right areas to fish those fish.
Okay, let's So, what do you think?
Too technical sometimes.
Okay. So first of all, the problem is very approachable. Obviously, people care, want to know fish, food resources. The one place where maybe you should have chosen your words slightly differently is the model part, projection. Projection, you project a movie, correct? That's what people will think about projection. So that's the part where, obviously for us, anybody did not understand? No, we all clearly understood the message, but some audience may have difficulties with this, with the technical part about the model and projection. So how would you change that? What do you think?
A computer model to predict the future.
Through the looking glass. Well, that's better.
I need to think about it.
Think about it, but it's something that, you know, one thing we need to do is do more research. Part of the research requires collecting information in the field, and some of the research may be using computers, where we use that information to see what might happen. And that's where maybe a little example. For example, if the temperature in the Arctic increases, this might result in this type of fish declining or this type of fisheries moving offshore, something like that. So examples are really, really useful. Perfect. Stay up front.
Okay, so
Your name.
my name is Brandy Stewart. I'm from the University of Minnesota, and my issue is chromium in leather tanneries. So problems are that we have industrial pollution coming from the tanneries, and then it reaches drinking water and people get cancer. Our solution is to treat the waste properly and safely contain it to keep it out of the drinking water. This benefits the workers. It keeps them safer working in these factories, and people and animals don't get sick. So what? We have billions of square meters of leather produced worldwide every year, and it's often in developing countries that don't have very many environmental regulations.
Fantastic. Comments? And again, that's a very, very important issue with a lot of implication, and I specifically like this social justice that you brought up at the end. The fact that, you know, we, the rich people, buy the leather, the contamination goes into the places where it's manufactured that are sometimes don't have regulations, and that's an issue that will track attention, that angle of social justice, in addition to the science. Thank you.
Thank you. My name is Norbert. I'm from the QST, from Japan. And so my issue is radiation monitoring due to a nuclear accident. And so what is the problem? In case of nuclear accident, the strontium-90 is also released. And the strontium is very similar like calcium, so it easily can be found in milk. And what is nowadays the problem? There is no real techniques what is suitable for breast milk analysis, because for milk analysis, relatively huge amount of sample is necessary. So what? Because as I mentioned, strontium very similar for calcium. So if a baby feed strontium-90, that is can incorporate the bone issues. So just giving unnecessary radiation dose. So what should be the solution? So we should improve a new measurement techniques or new measurement methods, and we should use the benefit of the mass spectrometry system, what is maybe should be suitable for this kind of measurements, but needs some kind of improvement, and in this case needs some kind of support and budget for this kind of research. And so also what is the benefit if we can improve method where a very small amount of milk could be enough for analysis, we can produce a kind of better and much more healthier life for the future generation.
Comments? I think you have two types of audience. You have your funding agency and maybe some general public, others that may be nursing. I want to do another exercise with you. Come on. And
You'll get put on the spot.
you're invited to a cocktail party, and you met this nice gentleman who's the ambassador of some country, and he's asking you about your research. I would like you to repeat what you did in a conversation.
So what do you do?
Okay, so what I'm doing, so I would like to do some kind of measurement just to because nowadays we have a kind of problem, so there is a called radiometric method. And radiometric method, we want to analyze the strontium in the huge amount of milk, maybe 250 milliliter or half sorry, or 500 milliliter milk. What is that if huge? So one mother cannot produce this huge amount of milk, so we need a kind of techniques. So you can ask why this kind of this is important, because strontium-90 is we can incorporate so in this case it's kind of necessary dose.
Do you want to ask me more questions?
Well, yeah, I mean, can I comment on this? Because, yeah, your ambassador might be an expert in Assyrian history and know nothing about isotopes or even what strontium-90 means, or maybe even not have a good idea of 100 milliliters. You know. So you're getting into quite a lot of detail about what you actually want to do, but what you want to do is make milk safe. And that's it, really. You want to make mother's milk safe with a new method that can easily detect whether it's unsafe. So you can simplify what you're trying to explain. It's a bit like an elevator. You know about elevator pitch? An elevator pitch where you know, between the ground floor and the fourth floor, in the 30 seconds you've got to explain what you do. As soon as you go into discussion of the ambassador's going to be looking over your shoulder, but that person in the room. I think that's fine.
Yeah,
It's
but
really difficult.
that's we're not like measuring the kinetic energy of some compound or another that nobody knows about. That's really important for so many people. And that's making it not simplistic, but just clear with the message. What I'm working on is making mother's milk safe. Yes.
So tell me about what you're doing.
Okay, so I'm doing radionuclide analysis, and this kind of things is important, especially in this accident. Now we have a kind of program, because for milk analysis, we need a big amount of samples, and the big amount of samples is not possible to collect from others, as just big. So in this case, I would like to develop a new method where a very small amount of milk is sufficient for analysis.
And here I think radioisotope analysis may be too overdeveloped.
Oh, yeah.
But an example, maybe most people heard about Chernobyl or about what happened in Fukushima. So you use that, in such accidents, there's release of radioactive material into the environment, which can be gone or
Just let it be
stored.
radiation contamination.
Exactly.
Yeah, I think you can talk about radioactive strontium. I would say, I mentioned I was at BBC for 6 weeks. The very first thing they told me is you cannot use the word isotope. You talk about geochemistry, you can't use the word isotope. You talk about heavy oxygen or light oxygen. That's it.
Or different
You know,
oxygen, different
So-
compounds.
so in your case, you could talk with, say, radioactive strontium in milk, the problem because it replaces calcium. People know the calcium in milk.
Yeah, because they take vitamins. Cool, thank you. Do you want to do another example? Or did you come up front to share? Hey, you can stay up front here. I have chocolate for you.
Milk chocolate.
No strontium-90.
Oh, so bad.
It decayed, but that's
Thank you. So I'm Thai. I'm from Vietnam, and I'm doing postdoc in Taiwan, in the Institute of Earth Science in the Academy Sinica. So now I want to talk about the problem. Currently, I would like to talk about the education for the young scientists. What is the problem of that issues? That we have the problem is supervisor don't pay significant attention to educate the young scientists like student, PhD student. So what the student have to learn by themselves, like reading the paper, learn from the paper and from the book. But somehow that is not the, of course they need to self-study, but somehow not a good way, because reading paper just not so basically understanding or just surface, sometimes it's just surface understanding. And also the point of the student, PhD student, need to learn the method. I mean how to approach the problem and how to understand the problem and how to understand the fundamental problem, not just reading the some paper and learn from that. So the benefits is for the young scientists, for the younger generation, and we will have a good scientists in the future. Nowadays we have a lot of scientists, young scientists, but we are not sure how about our young scientists quality. Based on the PhD degree or paper they publish, I think that is not the way we evaluate or educate our young scientists. So the solution, I just want to give all you audience needs to discussion about this issue and give the solution for our generation of science.
An interesting and provocative presentation that actually I'm very happy that you brought up, because we have to remember that as scientists, right now I assume most of you are students, but as scientists, your job description is not only to do research, but also to educate the next generation of scientists, and thinking and putting time into how you communicate with your students and what their needs are as opposed to what your needs are is very important. I always tell my students, and you can ask them that, there's no one right here in this room, but there's some outside, that I work for them. That they don't work for me. I work for them. Because I'm there to make sure that they learn and they're successful in their future careers. And I'm available to help them be successful scientists. So that's something that I think we all should keep in mind when we move on with our careers and have a lot of mentees that we work with students. And you can do that already if you're working with undergraduate students or even with each other talking. We always contribute to each other. And with that, I think Becca is going next.
Yes. Ooh, presenter presentation slides. Okay, so as I said, I am Becca from Nature Geoscience, and I've been an editor at Nature Geoscience for a little over 2 years, and I'm actually based in our Shanghai office. And as I already mentioned when I introduced myself before, Nature has been around for 150 years, Nature Geoscience just for 10 years. And we clearly have this mandate to communicate science to scientists. But we also have a mandate to communicate science to the community that is interested in science, to the general public as well. So that's what I'm going to focus on today, is how we would take a scientific paper that is written for a scientific audience and how we try to communicate that to the public. So for us, it generally starts with a fully published, accepted paper. For you, it might start with a different trigger. So it might be that you're working on a certain volcano and it erupts, and therefore you have something to contribute. Or there's a funding body and you've got some money and you want to promote that. Or there's something in the news, say if you're working on radiation in milk and there's a big radiation accident, you may therefore have a different hook for the reason you want to communicate your work. But for us, it almost always starts with the actual paper. So what I'm going to do today is walk you through a paper that we published last year. And this paper was on microplastic contamination of riverbeds significantly reduced by catchment-wide flooding. And this is the abstract, which I do not expect you to read because I'm going to walk you through what this paper did and how we construct the abstract. And essentially, the abstract takes the format of kind of a mini paper. So in the beginning, it starts out with a brief explanation of what the scientific problem is. So here you can see that microplastic contamination is a pressing environmental concern, but we're not really sure about the sources, the stores, and the fluxes within rivers. Then we go on and we have a look at what the scientists have actually done. So they've gone to 40 sites across actually a region in Manchester, so northwest England, and they've classified by type, by size, by density, the microplastics in the sediments of those rivers. They then went back and reoccupied and resampled the same sites after a period of flooding between 2015 and 2016. Then there's a lot of information on the results of this study. So before the flooding, they found that there was contamination in these river sediments, whether they were in urban areas or rural areas. They had a quantity of, I think, over 500,000 particles per square meter. And then after the flooding event, they saw that the microplastics were dramatically reduced. So I think 70% of the microplastic load that was originally stored in these rivers was flushed out thanks to the flooding event. And actually it was eradicated entirely from 7 of the sites.
And in the end, they have their conclusion that microplastic contamination can be removed from river sediments during flooding. So this is kind of what Adina was saying before. When we're talking to scientists, we tend to give a lot of information at the beginning, and it's only at the very end that we dump our conclusion. This is now the press release that we as an editorial office wrote for this paper. So the first thing to probably note is that the title has changed quite a lot as well. And the first thing we put in the press release is actually the conclusion. So the first thing that I want my general public to understand, and if there's nothing else that they read, they'll know the purpose of that paper, which is that floods can flush out microplastics. Then we give a lot more information about the details of the background. We don't assume that people know what microplastics are. We explain the size. And this actually became quite important when someone contacted The Guardian to ask them about this 5mm definition. The Guardian then contacted us to make sure that we had our sources correct. So making sure you get this information correct is important. We also explain how microplastics are generated, so that some are deliberately manufactured, say in your face creams or washes, but others are the degradation of larger plastics. So we explain more about the environmental problem. Before going into the details of the study, we still do include some of those methods, so we explain that they go and sample sites before flooding and after flooding. And we also still include a lot of the actual details of the results, because this is where the kind of trust in science comes from. But importantly, the conclusion is the first thing. It's only if they're interested that they get bogged down in the details of the study. And so there's two, if you compare the differences between the two, on the left-hand side we have the abstract, and on the right-hand side we have the press release. And you can see that they're basically inverted. For the abstract, you end with the conclusion. The press release, you start with the conclusion. And I would actually say that this style of communication can probably be applied to most of the ways that you discuss your science. Even at a conference, if you're in a session that's slightly outside of your field, is it always appropriate to dump your conclusions right at the end of your talk? Or should you maybe be highlighting what the take-home message is early on before someone's drifted away in the 10 minutes of your speech? So what did the press actually do with this? It went to the BBC, and they did a pretty nice, pretty matter-of-fact, there isn't a lot of attention-grabbing stuff going on here. Microplastics are littering riverbeds. The particles contaminate the riverbeds throughout the UK, and the research suggests that. So it's pretty factual. You can argue if it's throughout the UK or not. It went to Wired, again, researchers in the northwest of England have found evidence of severe microplastic pollution in British waterways. It got translated not into Spanish, but also into German, which is great. It means your paper's getting a lot more reach. And then things got a little bit more interesting in terms of the press coverage. So this was the front page of The Guardian for a while. And what The Guardian was saying, in this full quote, a study reveals highest microplastic pollution levels ever recorded in a river in Manchester. The Huffington Post also took a similar angle. Highest recorded levels of microplastics found in a Manchester river. And they went on to say that this was the largest recorded level of microplastics pollution in the world that's been found. Factually correct. I can't argue with it, but that's because no other real studies had measured microplastics. So they weren't wrong, but whether they were actually telling the truth is certainly debatable. It happens. There's only so much you can do to control it. So the other thing to think about here, I think, is science for scientists versus science for the general public. So on the left-hand side, you have the classic Nature Geoscience paper. We do include figures, but they don't tend to have the multimedia aspect that other press might. So you can see here, we have a video of some of the sampling that was happening. You've got a nice image of actually microplastic contamination in the oceans that The Guardian used, and slightly just more interactive things that are going to interest people. Graphs, text. A solid blank page of A4 text is not necessarily going to grab a lot of readers for your work. And again, just think about the triangle. Scientific papers tend to weigh you down with a lot of information at the beginning and give you a conclusion at the end. When you're communicating to other people, think about having your conclusions right at the top. So, things to think about: know your audience. Things we've already spoken about. What do your audience already know? What's their level of understanding? What do you want them to know? What's the one sentence that you want them to retain. Details are often less important than the big picture, so make sure you give the big picture first. If they're interested, they will carry on to read or they will ask you more questions. Is there any room for misinterpretation in what you're saying? This goes a lot to what Adina was saying around jargon that we use. It's incredibly important. You can see that what I consider to be quite a simple story on these microplastics was easily somewhat misrepresented in some of the media. You can't always control it, but you can do your best to give the baseline facts accurately. Think about multimedia. For instance, we find that when we tweet about our papers, if we are able to put a GIF with that tweet, the tweets get much more interaction. So just simple things like that. If you have a video of an experiment, you might think it looks boring, but adding a GIF of that to your tweet might increase engagement. And the final thing is, don't be scared to engage and practice this. I actually think sometimes we're so used to being critical of our own work that we feel like we have to put in all these caveats, and we know it's a very complicated message that we're putting out there, but someone has to do it, and I think we are the best place to do that. So try it, see what works, see what doesn't work. And then the final thing is on the bottom is our website, and actually a lot of our press releases go on our website. So you can look at the paper next to the press release and just see some examples of how we communicate papers to press release. Done. Sure, I can take some questions now.
Do you ever interview the authors, or are you writing a press release because you read my paper and you and I are probably not engaging, or email questions, or how does that work?
So from our point of view, we prepare the press release, that then goes to our press office. They then link that up, and I think Tom will probably talk about this a little bit more in terms of how it then turns into an article in the press. So no, we're not interviewing the authors. If, as an author, you are also press releasing from your university, for example, then it's best if you also contact the press office of the journal or the editor that's handling it, so that we can all together coordinate a press release, or to make sure at least that everyone's press is going at the same time. We do sometimes get into difficulties of people in general unknowingly breaking their own paper embargoes, so potentially tweeting that they had a paper accepted before it's officially been accepted. Good point, jargon word. So, how do I explain embargo? It's basically the period of time in which you shouldn't be putting online or discussing in public the results of your paper. So after, as a journal, we have accepted your work, if you then go and tweet about it before it's actually online, before anyone can access your work, you're potentially diminishing the amount of attention your work will get because it's kind of diffused.
Okay, diluting. Diluting the message.
Yeah, exactly, diluting the effect. So our aim is that the day that your paper goes online is the day that the press also gets access, so that people can refer to your article, they can see the original source, they can see all the science, as opposed to kind of almost hearing a rumor about the work and then not being able to access the work. That being said, when we press release the work, the journalists will have access to a copy of the paper so that they can go and do research and interview scientists, and they can contact relevant people. Yes?
So I was just wondering, I mean, I don't like use social media or anything, but I know that like back when I did, if I was going through any of these scientific things, I would just kind of scroll with my thumb. I was stopped for, I was like, so should I repeat what I said? Okay, I'll say that again. So like, I don't use social media so much, but I'm thinking I probably will in the future. But when I used to use it, I would just scroll with my thumb like this, and I would spend like maximum 10 seconds per post. So I'm just wondering, like, how do you really grab somebody's attention within like 10 seconds?
It's a very good question, and something that I think a lot of people are playing with. And as a journal, it's not our primary focus. Again, we find if we put a figure with the tweet, that gets more engagement. If we put a GIF with the tweet, that gets even more engagement.
Retweet to your community because they're interested.
Yeah.
Spend more time.
And then they will
And also kind of identify the people who, especially on Twitter, who are kind of hubs, so that they have a big following. If they're going to be engaging with it, that's likely that other people will then get access to it. Instagram is something that we don't do. Some of the journals do have an Instagram. That's a whole different game in terms of who your audience is and engagement levels as well. Making use of stories tends to be quite interesting. A lot of people find good engagement more with stories than with just an Instagram post that people do scroll through. Whereas if it's a video of someone talking, people tend to kind of sit and actually listen to those. So I think it's about playing around with it and finding your voice and your audience.
Let's thank my target.
I think while I'm trying to, sorry, I'm Tom Parker. While I'm trying to do this, there's a couple of things that are useful to bring up from what Becca said about tweeting. We had, I was doing some work for another organization a few months ago on a prize that we put out for work which had shown that original work couldn't be reproduced. And it's a fairly dull story because no one really is going to cover something like that. But we managed to get a very prominent media personality, science media personality in Britain to retweet it. And he has 600,000 followers. So suddenly, you know, we struck lucky and it just went everywhere. It didn't get into the media, but it reached 600,000 people, which is exactly the end product we wanted to do. So I don't think that we can actually underestimate the role of social media in reaching people. Okay, I'm Tom Parkhill. As I explained previously, I'm the press officer. And what I want to talk about a little bit is how you work with a press officer. And first thing is, I'll tell you what a press officer does. It's to take the information that comes from your work, whatever format your work is, and to put it to people outside the field. That's normally the general public, but as Adina and Becca has said, it can be different audiences, and I will come back to that in a little while. So the practical things that we do is summarize the work in terms that people can understand, distribute, deal with journalists, and generally advise. This is something that we put out last week, work being presented at a conference, into El Mundo, a Spanish newspaper, went into New York Times, went into The Sun. In part, this was because we did it, and in part, it also came out in Science. I'll come back to how that sort of cooperation we can do in just a moment. The fundamental points, I think, when you're actually dealing with a press officer. Now, a press officer is somebody who's going to help you take your work and send it out into the world. So it's your work, stay involved. I'm a press officer, I deal with 8 press releases at this conference. 2 weeks' time, as I said, I'm going to do another one. I'll move on. This is your work. You need to get it right, and you need to be quite assertive in dealing with a press officer to make sure that he or she doesn't exaggerate, doesn't push you in directions you don't want to go. You need to take advice from the press officer. Because the press officer has expertise, but you need to stay in command. So, identify what's the important things that you want to say, except it's a press release, not a scientific paper, so you will not get all the information out. And look, and remember that you have the expertise in the field, but the press officer has expertise in the press officer's field. So you need to balance these things. Okay, before you start, why are you doing what you want to say, who are your audience? As people have said, audience is actually one of the most important things, and I will go back to it again because it is so important. Now if you look at something like this, let's just say audience size, the complexity of what people will understand. Right at the top, people in the room. If you're actually, imagine you're presenting something here at Goldschmidt. So the people in the room, you would expect to understand most of what you say. Then maybe the people in the field. So, you know, you're moving, your audience size is increasing. People at Goldschmidt, geologists. And then maybe you're moving into the general public area. So your audience size increases hugely. The level of complexity has to go down so that people understand that. And then generally interested and not interested. Now, what a press officer would tend to deal with would be the line roughly between people at the conference and geologists, or geologists and interested in science. You can communicate with the people in the room and the people in your field perfectly well. So what we have to do is we actually have to change what you're saying into a form that people in the lower part of the diagram can understand. But there are other audiences too, as Adina has said. Now, let's look at this story. This is one that we ended up not doing as a press release. We considered it being presented at the conference, occurrence of pharmaceutical compounds in natural springs. It's a Spanish story. Aside from the people here, can you think of any other people, and I'm talking about an audience outside the room, outside the conference, who might be interested? Any suggestions? Yeah, exactly. Anyone, basically. Because what applies to spring waters in Spain applies to spring waters everywhere. But you can even sort of segment that a little bit more. If you look at some of the other things, these are just some of the things we come up with. Local news. If you live near a spring, your local news is going to be interested in something like that. People who are interested in health, medicine, nutrition, environment, politics, whatever, anyone. So you can actually, what actually starts off as being something that you think is very, very sciencey can actually include just about anybody. So remember that. Sometimes you actually have to adapt what you do to try and reach these audiences. For example, if I'm sending out a press release, I would send it out generally. But if I know it's happening in Spain, and it has Spanish local interest, then I would put some bias towards sending things to Spanish newspapers and Spanish websites, for example. So, I'll give you another example of this. The Women's Health Initiative study. It was a study that came out 17 years ago that wrecked hormone replacement therapy. That's the HRT that's mentioned there. Basically, it said it caused cancer and stroke. And there was a single press release and a single press conference. And this is how the British newspapers covered it. These are the headlines from the British newspapers. At the top, the likes of The Guardian, talking about HRT study cancelled over cancer and stroke. As you move down to the mid-market, linked to breast cancer, so it moves away from stroke and becomes cancer because cancer is more scary. And then by the time you get down to the mass market, danger, 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 danger. They know their audience. And to show exactly how people really know their audience, the same day the Financial Times said it might hit the share prices of the company that made the drug. So, that is segmenting your audience. When you're starting to work with a press officer, also think, is it too early? Do your co-workers agree in doing it? Do they know you're doing it? Are they involved? Is the science contested? Are you putting forward something revolutionary that you're going to have to field seriously hard questions with? And then you have to think about publication as well. Now, in some cases, like Becca, you'll actually be sending information to a journal, and they will deal with the press. With something like Goldschmidt, you're actually dealing with me. People are often quite worried about presenting material at a conference in case that interferes with later publication. In fact, for most journals, it's not a problem. I've actually contacted about 35 journals. About 7 of them have reservations, most don't. So I think the important thing is, as I put at the bottom, ask the press officer, ask the journal. And this is how a press officer can help you move things forward. So sometimes you also have to think, where does the story belong? Let's say you're putting out an article and it's being published in Nature Geoscience, it belongs with them. Let's say you're putting something into, you're doing something that comes from Goldschmidt, it belongs to Goldschmidt. But it might also belong to Nature Geoscience, because they might be publishing at the same time. Your funding body might want to be mentioned, your university might want to be mentioned. And so you have to think about who's involved, and maybe even deal with multiple press officers. Here's an example of the story I showed you in El Mundo earlier. This was Suzette Tinneman. And this is Suzette. She produced this brilliant photograph. Getting a good photograph is always good. And this led to press releases being issued by Goldschmidt, by Science, and the Australian National University. Now, Adina mentioned So What. There's another press release that I'm putting out today, which is about, as I say here, a new method to measure oxygen concentrations in Triassic minerals. That is the science. What actually the guy has found is the oxygen levels have increased at the time that the dinosaurs suddenly started to run around North America, to increase in North America. And so that is actually what the hook is going to be. And so what you're doing is, here, you're actually reporting the science, but you're using the dinosaurs to get people to read the science. And sometimes you have to do that when you're designing a press release, because sometimes the science is quite dull, quite complex, people won't understand it. You actually have to look at what the final point is, what will actually interest people, and then introduce the science. As long as you introduce the science at some point, you know, that's essential. That's something. Dinosaurs are great.
You find a dinosaur with the feathers sticking out its nose, you get a science paper right there.
When I saw that, I could have kissed the guy. So we're hoping that that's in the papers. One thing that Becca was actually saying was, one thing you asked was, how do you grab people's attention? I'll just digress a little bit with that. Normally we send out press releases by email. We send them out through organizations called Eureka Alert, Alpha Galileo. They're big organizations, run big science organizations like the American Association for Advancement of Science. And they will send out 100, 150, 200 press releases a day to science journalists. So if you're a science journalist, and remember, they're not geochemistry journalists, they're science journalists. They might deal with cancer in the morning, because they deal with medicine, and they might deal with geochemistry in the afternoon, if we're lucky. What you really have to do is, out of the 150 that you read, you're going to ignore 147 of them. And so you really have to grab their attention. You said 10 seconds. 10 seconds is much too long. Really, you have to have that in the first headline that makes them want to read on. And when you're actually going down through the press release, you don't put in anything that will stop them, you know, until they're actually in reading mode and they're going down. So that's the only way that you can do it, and you get lucky. It's not an exact science. If you have a superb story coming out from somewhere else, you're not going to make it. So it's very, very competitive. And the other thing is, the ultimate people that you're actually aiming at are not necessarily even people who are interested in science. If you buy a newspaper like The Guardian, you don't buy it to read the science. You buy it to read the politics and the sport and so on. So it's competitive in the sense that it's competing with other news. And you have to remember that you actually have to make it interesting enough so it competes with Boris Johnson and Donald Trump. No, don't worry, I don't want to think about it. Okay, this is Eureka Alert, and this is what I've been talking about. These are just some of the examples of the stories that you come out with. Just want to say briefly, lots of people want to put more depth into the stories. You can do that through a feature. A feature is something that you might get in something like New Scientist, Sunday newspaper. But they tend to appear in one news outlet. What we tend to do as press officers is deal with news stories. So they can actually go out in press releases and they can go to lots of places. News is time sensitive. The science will be simplified. That's not a problem as long as it's accurate. And you need to tell a story, not just the facts. I'm repeating that, not just the facts. Now, at this point, I'm going to actually just briefly come out and show you a little video. Figure out how to do it. It's okay, I'm here.
One of the key early theories of science communication is what is known as the information deficit model.
Deficit model says there is certain scientific knowledge that the public should know, and if they don't know it, they need to know it. And so somehow we have to educate the public in this knowledge.
We can think about the deficit model like this: that scientific knowledge is inherently worth knowing, that the public should listen to scientists, and that the best way to convince people is to provide more scientific facts.
Know from lots of evidence that the deficit model doesn't work, that if you try to,
see people as just blank slates waiting to be filled up with information that will then suddenly change their behaviour. We know that doesn't change their behaviour.
The deficit model carries with it this connotation that people are lacking. They lack knowledge that they should have.
The assumption that divisions on social consensus can be alleviated by flooding people with more information has been shown to be problematic on a whole range of issues. We've already discussed tobacco, but so too climate change and vaccination. On all of these issues, the facts alone just haven't convinced people to take action.
And that, I think, is one of the fundamental points in actually dealing with a mass audience. We've seen it, as I said there, with trying to talk to people about climate change. It doesn't work if you just present people with facts. You have to give them a story. And that's really fundamental, because that's the way humans are designed. We're designed to listen to stories.
One of the key...
So, get them interested in your work, not just the facts. This is actually aimed at a press officer. Press officer is your first audience. You actually have to sell your work to the press officer, so the press officer goes, wow, this is really good. See, if he or she doesn't understand it, then you're not explaining it well. So you need to sell it to the press officer, and you need to stay in charge, but take some advice. And remember, even journalists are sometimes not specialists. Press officers are not specialists. This is from last year. CNN, one of the biggest news organizations in the world, wrote to me about radiation levels in Fukushima. Professor Satoshi was doing some work on it. We sent it a press release. And CNN, we may be a bit delayed getting an interview as we have lots of staff tied up in a bridge collapse in Italy and an attack in London, a terrorist attack. And then they say, a few questions about what it means to the average person. You might think this is not good journalism. This is great journalism. They're telling the professor and me, they're not specialists, they want people to explain things to them. And you have to be very, very good to deal with this level of work, from terrorism to radiation levels in Fukushima. So the journalists are normally very good, but they're not specialists. We have to make it easy for them. I would point you, just finishing up, at this career feature in Nature last year on how to deal with a press officer. Very, very good. So we'll maybe come back to that later. And in summary, that's it. Think about your audience, think about your goals, stay in charge. Journalists are great fun to work with. They want a story from you. And they'll work with you to give you a story. Okay, thank you.
And practice your message. Okay, we have about 5 minutes before we have to let the session that starts here. So, anybody has more questions? This is the right time.
Do you think it would be very important to have scientists working in mass media, to be more careful with this kind of distortion of the original message, and because sometimes the mass media create a craze or something that out of a small thing.
Yeah, I think we need to, as Becca said, try and build in to the communications certainty, as much certainty as we can give, so that it doesn't actually move too far away from the original story. The very, very first press release I ever put out was on the possibility of a male contraceptive. And within a day, the story had moved from the science to, would you trust your boyfriend to take a male contraceptive? And so it just moved, and my story was lost. You can close that down a little bit. You can actually, sometimes if you're actually issuing material, you can say, the important thing is this, so that people have no excuse for actually moving away from what the story is. But yeah, it is important to have more people, more scientists in the media. Yeah.
My comment on that, that's how I ended up doing a stint with the BBC. And that came about through previous experiences of science reporting in the UK in particular on the MMR vaccine, which had been linked to autism incorrectly, but it had been taken up wholesale by the media and by the population as a result. So there was a problem with vaccination programs because people believed that program in the UK is to get scientists working alongside journalists and actually communicating both ways. And I think it's as important for scientists to understand what journalists want as it is for science to tell journalists what they should be doing, because that's not going to work. And everything Tom has said is right. Journalists are only interested in stories. They're not interested in educating or even providing information. They're interested in readers. And so they want something that is going to interest their readers. And so I think that's why occasionally things go beyond where you expect them to be. So I just wanted to give one example. My best story in my stint at the BBC. And everyone, all of the journalists were looking at the number of pages to their story as a league table. My best story was about a Barkan sand dune in Tunisia. Okay? So this is a sand dune in Tunisia. It was from a paper that was published not in a tier 1 journal, in a rather obscure sedimentology journal. But the interesting thing about it was this sand dune was about to inundate the Star Wars set. So the sand dune was moving, and the Star Wars set is a tourist attraction in Tunisia. And so this story that had the greatest hits, it beat Jay-Z changes his name. And it was only popular because it had Star Wars in the title. People didn't want to read about Barkan dunes, but you can't. So if there is a book that can draw people in, that's very valuable. And the things like highest, smallest, biggest, things that are quirky, things that are counterintuitive. Those sort of things that I think really do work.
Well, thank you everybody for coming to the workshops. There's lots of other workshops throughout the week, so even if you haven't registered, if you want to go, as long as the people that are registered take their lunches, there's always extras and you can participate.
And if you want to talk to us about it, come see us.
Yeah, we're here throughout the week.